As I said, game development was the #1 interest, and yeah, it's something that I've been doing for many years, mostly as a hobby, but now lately more professionally, and have a 50% position in doing that. Okay, let's take it away. I like the quote by one of my favorite game developers. The game designer should be making a world which the player is just a small part. The player is the boss. It's your duty to entertain him or her. Said by John Mæland. He's the co-founder of id Software, and he's a legendary game programmer. He basically invented a lot of the 3D engine stuff. And what I really like about him, though he became a billionaire by now, they made huge success with the companies, but he still managed to stay in the position of being the game engine developer, true to his core, not becoming like a middle manager or boss. No, he stayed there up until very recently, being the engine developers. And the company knew how to care for him, being in that position. I want to start off a little bit with the history of gaming. And as you can see there, I put some dates. Pong, which you can say was the first game that really was known, first out in 1972. So it's a huge span of years. As you can see, that's like kind of air hockey made electronically, but at that time that was difficult to make. You know, it took a lot of effort to get it running properly and so on the limited hardware they had. Fast forward, Super Mario Bros. 1985, hugely popular, still popular today. It's a classic. More recent times you have Angry Birds, 2009. That's the first massive success, I would say. Maybe there was some before, but the truly known success for the handhelds and mobiles, tablets, touch device, etc. And it opened up a whole new group of players. So the gaming market has just expanded. So the old players with the consoles, with the PCs, etc. are still there and growing. But there's a new market with the mobile handhelds. Look at Candy Crush. Same thing, massively popular. Released in 2012. Still, today, they have millions and millions of players. So it's clearly that it's a massive market there for gaming. Common for all of these, I want to say, there's 2D games. So 2D game, it started with 2D games, still very valid today. 3D games, entirely different beast. I would say Doom in 1993, which really put it on the map. Again, id Software, John Mæland, he wrote the engine. As you can see from the first picture there, it's all with pixels, software rendering. Everything is software rendered. And to get that running on those computers, you really had to limit the size of the textures. You see, to get shaders working, it was very computational expensive, but he managed to pull it off. Then you jump until you have Quake 2, 1997. As you see, there was a big change in the layout there. You see the textures has increased resolution, the textures and also the fidelity of the whole game massively improved. So one can think, well, what happened there? I'll get into that later, but that's a huge paradigm shift. I wanted to jump in like Half-Life 2, 2004. Now you see it's getting, wow, it's getting, the realism is really, really good. It's not entirely there, it's still, you can see it's a game and so on, but it's like, it's really immersive feeling. And today, or last year, Battlefield 1. If you look at the rendering quality there, it's almost photorealistic. So today, with the proper hardware and the right game, it's almost there to the point of this could be real, like it's a filmatic scene, but it's rendered in real time. Just want to quickly go through different type of games. And all type of games are still popular today. As you can see, anybody here who are familiar with the titles? Anybody want to do a pick? See if you can guess all the titles.
Skyrim.
Anybody?
Owlboy.
Owlboy.
Super Meat Boy.
Counter-Strike.
Counter-Strike.
There we go. Almost there.
Minecraft.
Top left. Nobody said top left.
Civilization.
Civilization 6.
Yeah, UFO.
And of course, I think you know the
UFO Hunter.
Yeah.
Yeah, UFO Hunter. And then we have StarCraft 2 at the top. But the common factor you see here, this is games being played today. And they're all very, very different. From high fidelity 3D games to 2D games to pixel art to games where you create your own content, like in Minecraft, Skyrim, huge world, exploring, StarCraft, very competitive, RTS, and the down in the middle. Do you know which one? Nobody picked that one yet. It's EVE Online, made by ICCP. And the fascinating about that scene there, that is the biggest online battle ever being fought, virtually. There are players playing for years and years and years, accumulating play them good services, using real money to get these titans, as they call the biggest battleships you can have there. And it was a massive clash, and it was a lot. It was a value worth 70 billion of virtual currency was lost in that online battle, and that is translated to real money. A lot of real money was lost in a virtual battle, and thousands of players on it. So just see, it's kind of crazy, you know. So it's fascinating to see the games and how different they are. That's good. Okay, why would you want to make a 2D game? It's less complex coding and math, obviously. Less demand on artists, and this is also a big one. And you have a significantly larger base of target units. Still, you have to put limits on like how much fidelity you can put in the game compared to what hardware you have. So with 2D games you can basically reach nearly any device. But with 3D it's more limited, you have to think more through the target group, etc. Why 3D? More freedom of expression, you have another axis. More immersive player experience. You can't really dive into the 2D world, but a 3D world with the VR sets and so on, you're more like immersed into the game. And still it seems like customers are more willing to pay for a well-made 3D game. They're willing to pay up front. But that seems harder to do with a 2D game. Of course the budgets are higher, it costs more to develop and so on, but you need to know your market. So I want to do a little bit about software versus hardware rendering. In the past, they didn't have anything they called hardware rendering. So all the calculations for the game were done on CPU. It's very intensive, and that was a limiting factor on how well you can make a game, how well it looked like. The hardware rendering, which I'll go into a little bit later, hit mass market adoption, I would say, around 1998 with the Voodoo 2 by 3DFX. And that was a graphics card where you had to use a normal 2D graphic card and then a special 3D accelerator and use a VGA cable to bridge them together. And that was the first, but this was really like, wow, it just lifted the whole experience to a new level. So because with hardware you have a vastly improved 3D experience. Then I want to dig a little bit into graphic APIs. If you want to start making a game, you can start all the way from the ground up, but you will never finish anything because there are layers upon layers upon layers of software which you need to utilize to finish anything. So the two big ones I would say now is you have OpenGL, and also later OpenGL ES for the mobiles, but it's a derivative of OpenGL by the Kronos group. Then you have Direct 3D, or more commonly known as DirectX, which includes I/O and sound as well as rendering, which is a Microsoft product. And lately you have a new, this is quite, I'm not sure, 2 years maybe, 1 year. You have a Vulkan, which is a new API made by the Kronos group. And that seems to have quite fast adoption now, so I have good hopes for Vulkan being a new choice. As well as Apple made Metal, which is also very new, but so far as I know it's Apple only with iOS or something. But it seems good, but it's more limited to the extent of units you can reach. But to have graphic APIs, that is just a tool on the way. But to make a complete game, it takes a lot more. So a lot of people who started out, let's say 10 years ago and so on, then the number of game engines were skittish, they were never really finished, and people set out to make their own game engine. Yeah, I'll make my own game engine. Or usually they had an idea, okay, I'll make this great game, but let's start. Wait a minute, I kind of need a game engine to get this going, you know. Then they start working on the game engine, and they never made the game. But it might ended up having a game engine. So that's why we have today more than 175 game engines. I checked on Wikipedia before I came in. A lot of them started as games, but they ended up as game engines. So my advice would say, okay, if you want to make a game, focus on the game and not the game engine. Tools are good today. And there are many good game engines, but I would say there are 2 game engines that will stand out from the crowd. And that would be Unity. Unity started as a 2D engine. Well, it started out as a Mac OS only. They mostly focused on 2D, and then they were very early to target the mobiles and the new platforms, and that made up their success. And they ported for a Windows development tool as well. They managed to quickly expand to become the go-to, the game engine. It's not the fastest, like 3D rendering is not the fastest, but the tool sets are very good, and the community is very good. And the adoption is what makes people choose that. I'd also say the scripting language. Use C# scripting language. I believe a lot of people prefer that over, for example, C++ or Unreal script, perhaps, which is like in Unreal Engine you have their own scripting language. It's going to taste. I never worked a lot with Unreal Engine, so I have to go for Unity and talk for Unity. But it seems like these 2 are now the ones competing on being the winner. Quick shot of how the editor of Unity looks like. As you see, there is UFO Hunter, a little bit of stuff going on. And this is how the Unreal editor looks like. I know someone here has more experience. Is there anyone? There's one guy over there, yeah. So you could probably do a few words about that on a later stage, in the Q&A session, perhaps. So, but I know that they are both. Seems to be like either you choose Unreal or Unity these days when it comes to, because they seem to be playing a little bit catching up. Unity trying to catch up with the 3D rendering, you know, have better performance, whereas Unreal tried to catch up with being able to target more platforms, be more flexible, etc. So it seems to, you know, reach each other.
Just shoot in a quick question here.
Yeah.
Like the biggest games you see on the market today,
Yeah.
are they typically made with one of these engines, or are they using custom engines? Are these engines primarily for... I know that Unreal Engine is used for quite a lot of the big games, but Unity, is it also used for a lot of the big games, or is it mainly smaller indie games and stuff?
Good question. The Unreal Engine is used for some large-scale games, definitely large-scale World 3D World games. Unity is not being used that often to large scale because basically up until now the performance hasn't been good enough for a large scale, but it's used a lot in 2D games, also commercial successes for 2D games on mobile platforms.
Are they both free, or is it the cost?
You can start free.
Okay.
Start free. They have slightly different revenue models.
Royalties or something, isn't it?
In Real there is some royalty stuff. With Unity there is a front cost. It's free, the first edition you can release for free, but you need a splash screen. You can update to professional level, which is quite cheap actually. I guess $35 per month or something.
$35 per month.
Yeah,
So
subscription.
not too bad.
Then you can release everything, and then if you want to go professional level, which you need to do if you have a revenue for more than $200,000 per year, the company you need to upgrade as well, licensing. Whereas I think with Unreal they take a cut on your profit. It used to be like this. I don't know exactly.
I think it's if you earn more than $100,000, they take 3% after tax or something.
Yeah, so it's still that model. Okay. Mm. But as you said, not these game engines are usually the entry point and so on. Big studios, they have their own, like DICE, for example, with the Battlefield series. They use the Frost engine, which they made in-house and so on. So there are many studios who still make their own engines and keep it as their proprietary, let's say, yeah, benefit, competition point, let's say. I do not want to license it out. Or it could be, but they charge a lot of money, for example. Alright, quickly, I need to jump on here. A little bit of technical stuff. 3D math, the famous game loop and performance. This go a little bit into the programming stuff and the technical of game, but also specific games compared to other software and so on. Jump right into the heavy stuff. Okay, when you want to you have a 3D world and want to position or scale something, use vectors. And with vectors, typically you have, you can imagine a virtual space where you have a point of origin with three X, Y, and Z coordinates. And usually you have this world with a point of origin. You just have to define where is the point of origin. But every local object has also their own internal axis with the rotation. But basically you can say, if you look at the illustration, you can stretch vectors out the point. So you do calculate position, scale and rotation from the origin of everything. And this can have some implications. Usually use 32-bit floating point resolution. And that can have some negative impact on how accurate, for example, if you're a large-scale world, how does that object look like at far distance compared to close to the origin? And the resolution of the calculation goes down because you only have the 32-bit of resolution. So if you've seen games where you have something called set depth flickering, you've seen some of the textures flicker. That is typically because it's far away from the origin point, and the GPU, because they do fast calculations, so they do some, they cheat, you know, they cannot do float 64 and so on. They have to do the calculation very fast, so the accuracy goes down. And that's why you see you can't exactly determine whether it should be there or there. So every iteration it does, it misses a little bit, and then if two textures are vertices are very close to each other, you can see they flicker in and out. That's called a set depth flickering. Just a very quick code snippet here of, for example, you have a position of an object, and then you want to move that object using the physics engine. And the point to take away here is like you cannot test for equality. You have to use hysteresis. You have to be approximate to, because everything is like normal. It's like true or false. but very often when you work with 3D math, you have to be, is it within the boundaries or not? Because of the inaccuracy and calculations and so on. And also you can see there in this update loop, at the very end there is like time dot delta time, which means because the rendering is not exact on the hardware, it varies on every iteration what's going on in the scene and so on. So to get a smooth transition, you need to take into account how much time was spent, so you can always do that. So the transitions will be like, it will tell the engine at one frame if it spent a lot of time, then it can move this far. But if it, for example, computed faster, then it can do a smaller jump step. Rotation. Euler angles. It's easy to understand. Rotation is relative to axis, but you have a problem with this, and it's called the gimbal lock. As you can see from the plane there, it's fairly easy to understand your pitch, yaw, roll, orientation. But you see if the middle illustration there, you see the axis follows the plane. So meaning, if you look at the right illustration, if you have the orientation of the rotation is overlapping, then you call something called a gimbal lock, and you do not have a reference between the axes. It approaches zero. So there are some cases in the engines, and you need to know about this, where you use Euler type of rotation functions for this, that when you approach certain unlucky rotation situation, the accuracy will be very low. It cannot determine, so you have to cheat. When you approach this condition, you need to do a cheat to jump over. So that's why you have to usually use Euler angles only when you are sure that you're going to rotate around one axis, and that's it. Not to do that you can risk getting to the gimbal lock situation. Then they came up with quaternions. It's even hard to say the word, and it's harder to visualize and understand. It's just more complicated to wrap your head around it. But with that, you don't have a gimbal lock problem, and it does also calculate faster than matrix. Basically, the quaternion is, you do not take into account the worlds, but you take you use it for interpolation. You have how much you did rotate, and then you take from that point, and you can accumulate from your point of origin to the next one. So a technique you use for accuracy, there's something called normalized vectors. The vectors are large, you know, they have you have rounding errors basically during calculations. You have to basically drag it back to normalized, which means unit vectors. It's quite technical here now, but I think some of you guys can follow this. It's supposed to be so there is an advantage with quaternion, but harder to visualize and understand. Finally, we have the matrix. Matrix most common, like that. The using matrix for rotation calculation is used on all like 3D software packages, for example, 3D Studio, etc., and all engineering type. They will use matrix because it doesn't matter the computational penalty you have. It's negligible in that situation. But whereas, you know, like in a game engine, you want everything to run as fast as possible. You know, then you usually use quaternions. And there are also some advantages with quaternions when it comes to interpolation. Yeah.
Quick question: do the APIs somehow abstract away these things?
Yes.
Because I would assume that from a programmer perspective, you would approach it in a simpler way most of the times, I guess.
Not really.
Like if you have an object, can you
Yes.
just say that it should rotate around this axis this many angles?
Yes and no. This is a good question. You do need to relate to it somehow. Like the APIs will provide you the functions. Like you don't have to actually Google the math behind it, but you do need to understand in what case you need to use what. because you do have matrix 4, you have matrix 3, you have quaternion, you have Euler angles, and all these are provided in Unity, in other engines, another engine called NeoAxis. So you do have to relate to which one you're using. That's why some understanding of what's going on there is actually necessary. You can, if you pick the wrong one, for example, you can have a situation that your game will behave very heretical because you use Euler type of angle rotation, and then you get into a situation where something is just jumping and what's going on there you don't understand, but that's rounding error going on and so on. So some understanding of this is actually necessary, believe it or not. Alright, the famous game loop. I think the text is a little how it looks like there. Yeah. So I just want to say, like with a normal software, you typically don't have to think so much about that it needs to run at a certain tick, that it needs to constantly update. Like just a typical programs are event driven. Okay, you click a button, something happens, you need to open a database, everything happens in sequence of what the user orders it to do and so on. And maybe it spawns off some background task and so on. But the difference, the big difference with games, usually they run continuously on a time loop. And it's the famous game loop, which is all game engines basically will have some kind of game loop implemented. The one on the left is a very simplified one, but it kind of, not to go into detail what it does, but I basically googled it, but it means that it prioritizes that the game updates what's going on in the world is very important. Like register the input from the user, that the enemies of the players need to be updated, the players and so on. So all these, the logics need to work, otherwise you have problems in the game. But whereas you can let the rendering suffer. So if your hardware doesn't allow you to render, for example, with the target 60 FPS, you can allow the amount of frames you can draw to the screen to drop, but the game still needs to calculate what's going on at the rate you set it to. You can, for example, half it and then use some technique to know that you halved it and so on, but it needs to run at some kind of fixed rate, otherwise the logic will mess up. But that's special with the games compared to other software packages. Performance. Everybody thinks, okay, games you need to tune and performance is alpha and so on. It used to be that many years ago. Today, you should just keep coding with good structure. The benefit you get from making some crazy optimizations early on is not worth it. And basically, the like pre-optimization is the no good at all. A little bit about shaders. Carefully use shaders. I'll get into what shaders are later on, but shaders are the ones who really can have a hit on performance. So that's what you see in typically PC games, and you can adjust a lot of settings, and most of these settings are related to shader settings. That's where the big power impact, but also visual fidelity comes with shaders. And post-processing is just a form of shaders. So a little bit about the shaders itself. This is programs that run on the GPU. They're not running on the CPU. There are small snippets and they run on the actual graphics card. You have two main competitors here. OpenGL shading language, which is used in OpenGL, and high-level shade language, which are used in Direct3D. Both of these is just intermediate language, which will of course compile into assembler runs on the GPU, etc. But the field of shader languages, that with big studios, they have their own people that work only with shaders. And you can see sometimes when they hire game developers, they ask for a shader expert. So you get a job as a shader programmer, exclusive. So that it's a field on its own within the graphics programming. Different shader types you have here. 2D shaders. That's basically pixel shaders. Like works on the texture and what color, how dark it should be based on the how much shadow there are and based on the lighting and so on. That's how should that one pixel look like. That's the pixel shaders taken care of. So you can imagine, like if you have a 4K resolution, it has to go through every pixel, have to calculate what color should that pixel have. Every frame. Yes.
Do you know why it's called shaders? Does it have anything to shade? You were saying that it calculates lighting and shade, and does it have anything to do with that, or is
Actually, very good question. I don't really know, but I would think it has to do with doing shadows, and shades, because that was the first use.
Yeah.
Of
now that's
shaders.
just
So,
one small part of it.
Yeah. So but now it's just a small part of it.
Okay.
But I think it initially started like that.
Yeah, I think that's correct.
Yeah.
I was working with a kind of 3D studio, similar software, and then it was only used for that.
Yeah.
In the beginning.
So that's the with 3D. So that basically covers the 2D shaders, pixel shaders. And in 3D we have something the most common is vertex shaders. And that is basically what translates the virtual 3D vertices, the points. You have all these vectors in vertices, and translated how it should look like on your display. Basically, we need to transform all this vector there, this vector there, this vector there. I need to truncate this and put it into the 2D viewpoint. This is what the vertex shader is taking care of. Then later you have some more esoteric like geometry shader, tessellation shaders, and also primitive shader, which is entirely a new thing. They are not so much used, but it's more special cases. Like for the most part, you need to deal with pixel shader and vertex shader. That's it. Then I have some little bit shader fun. I need to just quickly through because this is taking much more time than I expected.
No problem. You don't have a scale. I mean, just keep going as long as you.
Yeah.
Don't stress.
So I'm just gonna. So here we have a little bit nice tool for testing out shaders. See this little cool monkey? It's on my face. So basically, what I said, pixel shader, that's also called a fragment shader. That's one of the same thing. I didn't write this program, I just used some examples there, but it's good to illustrate what it does. So this compiles live. I can go in and do some changes, and you see that this is the orientation of the lighting. So you see the shadow changes based on this. This one is doing the checker pattern. If I can just click it properly, like can you see the number of checker patterns there increasing? Increase. This is all running on the GPU. It's being compiled, submitted to the GPU, and the graphics card will do all the calculation and present it there. So basically, yeah, it's fragment shaders, vertex shaders. This is a very simple one, just to show off this, but it's a whole like topic. This example is GLSL shader language. HLSL is similar, but it gets compiled to the graphics card to run there. So for example here, if you look at that code, it says you have the position, and then the last one is like that will be the set value, right? So you just okay, I double that. That means okay. You just shrink everything. So you can imagine, like you can do anything. You can stretch and drag and manipulate however you want these vectors using the vertex shaders. So a lot of stuff going on. You see the changes going on, like a bouncing ball or any animation or something. Animation, for example, very heavy in vertex shaders. Alright. So that's fun with shaders. Maybe we can give you the link later if you want to play with this. Alright. get back to start simple. Again, start simple. There's a very good reason for me saying that, because I did the opposite. As you can see there, okay, good example to start. Minesweeper. You can do that, yeah, if you want to learn. Start with Minesweeper. It's not hard. Snake, very good. You'll see later, the snake it's not that hard to make. But if it's the first time around, start there, see that you accomplish something, complete something, you know. Again, Arkanoid, simple, same type of game. Start out there. And then I want to show you, probably I need to go out again, because I'm not good with stupid PowerPoint. I have it ready here. So,
like game, and that's going to be the kind of game that used to be on cell phones before smartphones, since I'm a dinosaur. But the original version of the Snake game was also an arcade or PC game or something from the 70s. So we're going into here, we're going to do canvas equals document.get element by ID. It's most verbose and ugly where we have to be doing a little bit of interaction between the HTML and the JavaScript. Once we get this stuff sort of set up, it's not so bad. Get context, that's going to go to graphics context or buffer, and then we've got document.add event listener. Let's set up our keyboard hooks. Key down is all we really need since this game has momentum, like a function called key push, if I can spell push correctly. Let's go and get that stub set up, as well as start off our game on interval timer to call a game function 15 times every second. That's milliseconds, so we're dividing it into it. And so using low frame rate, since Snake works on a very low frame rate, we're going to have x velocity and y velocity values for our Snake. Part of the thing about Snake game, right, is that you just push the keys to make the character move, and it keeps on moving with momentum. We're going to switch on the key codes. Some people don't like switch cases. I don't like some people. But more importantly, key codes in particular are a great case for switch cases. It's kind of a natural fit, like peas and carrots. And I'm also going to say, even though I don't have all the key codes memorized because I'm not a nerd, okay, I'm a nerd. I'm not that much of a nerd, but after 1,000 hours training people one-on-one in game development stuff, you start to figure out that like 37 through 40 is the arrow keys, and it's left and then clockwise, because you need the kind of stuff on top of your head when you're walking people through stuff on Skype. So there's our input now handled. We also want to have our player positions equals py equals, let's start in the middle of the world. I'm thinking the middle works, thinking 20 by 20. So grid size and tile count will both be 20, because 20 times 20 is 400. And let's also have an apple x and an apple y as our goal, which will start at 15, 15, just to keep things simple. So player x is going to plus equal x velocity, and then player y is going to plus equal y velocity. To implement some wrap for those, so if px goes less than 0, some Snake games wrap, some games of Snake don't. This game's going to wrap. So, you know, there it is. Now, again, I'm going to warn, I can't say it enough times, because no matter how many times I mentioned the previous video, people still seem to got confused. This is not meant to be a follow-along tutorial at home. Obviously, I do those kind of things. They are much longer form and more detailed than this. So that's going to wrap the Y. Let's also do a context.fill style equals black. But I will say, too many people who come from the other end of the spectrum, where they have some experience, maybe first-year computer science students or whatever, or new to games, is the people who don't really have a sense for the fact that like there's a time and place for hacky coding. Right? That just because you can write rigorous code, and I can write rigorous code, and professionally I have, it's also, there's a time and place for writing some really just fast garbage. Because oftentimes, I'm a big believer in the Cerny method, which is built around the notion of rapid prototyping to prove concepts and throwaway code bases, where it's about standing up, how quickly I can get this gameplay testable. Ooh, so we're going to need a trail here for our trail. Hold on. Yeah, we're going to need an array for our player. Because one of the things about a Snake game, right, is it keeps track of all previous positions. Let's also keep one called tail to be how long our tail is supposed to be. Trail.length. And so anyway, there's value. I'm a strong believer in the notion, too, of you, your brain's a terrible emulator, is the way I like to explain it. That if you try to close your eyes and play like Pac-Man or Pong or Breakout or something, you can't, there's our X and Y, which remember part of the mechanics of a Snake game is if you step on your tail, you're in trouble, so we can do that really easily here by doing this. So if it matches on X and it matches on Y, then tail is going to go back to equal 5. Speaking of it matching, we also need to check and see if we step on that apple, Oh no, equals 5. If we step on the apple, then we want to increase our tail length, so tail plus plus. And as part of the 2, we want to randomize that, so math.floor, so it's an exact integer. And this is going to be math.random, which is 0 to 1 times tile count on each axis. Part of where I also got these sort of very, very rapid hacky demonstration techniques background. We also still need to pile this on. Trail.push, I'm going to, for the most part, I'm trying to show some kind of language agnostic code. One exception here will be this rapid instantiation of an object literal. It's going to help us out here a little. Also, we're going to trim down the tail, so if tail.length is greater than tail after being penalized, it'll shave it back down and also keep it a consistent length as we play by shifting off the end. Okay, so I think that's it for the code. Game.html. Anyway, the point I'm trying to make is that your brain can't really simulate real-time live-action gameplay. So if you're working on a game that's really strategic, then in that case, it is something you can paper prototype, you can board game prototype, etc. When it's a game that's really built around reaction times and angles and spin.
That was well done. I think he practiced a little bit before. I don't know. It's probably like it's fun to make, but it just shows that okay, you can make Snake fast. Yeah, if you have to spend a day, you know, working through that, no problem. Even a week, you know, but it's not that hard. But for a nerd like me, it's cool to see stuff like that. I saw others are also enjoying it. Hacky stuff, hacky stuff. All right. So I jump over that. This is my previous game project. I called it Gravitonia. It's a big world 3D game. My first real project. It's supposed to be networking, online. I'm not kidding. I spent probably around more than 5,000 hours on that project. It's insane. The scope is like, why on earth would I start out that way? Like, nah, this can't be too hard, you know? Like big world 3D engine, MMO style with virtual. It's impossible. But I was naive. Teams had 300 people working 3 years to make games like that. Well, I can do it in my spare time. Well, why not? You know, and I'm very stubborn, so I didn't give up until. So, without further ado, another video. What I did, and this is not actually the final. The promo video was maybe half a year before I really gave up the project. But
When was this?
I started the company. I started already the idea in 2008, and I did it on a hobby basis. I probably left it around 2013-14. Crazy stuff. But I had fun, and I learned a lot. Way too long, but Minecraft on steroids. 3 times.
Oh, so it's released? You did release it?
It was released for a short while. But I never... I had some technical problems, so I kind of had to redraw it. And I realized there was a lot of redoing to get it working as I wanted. And I kind of took the motivation away from it, and it kind of left it there. It's a bit a shame, really, because I spent a lot of time making that stuff. And it is actually more evolved than what you see here also. So it's still there, it still lingers, you know. I spent so much time. One day, you know, I want to take it forward. But the thing is that you just have to come clean with yourself, realize how much work is left, and how is your time best prioritized. So I think as much as you love your own baby, you know, you have your startup and you just never want to give up, sometimes you just have to give up for a moment. I might pull it forward, like thinking if we have some other successes, but it can be some hobby. Okay, I get 3 guys plus me, we can work on it a little bit and just finish it, just to have done it, you know. It would feel good, it's just a feel-good project. But I don't think it's worth pursuing it, like, if for financial reasons, for example. Lesson learned. So don't start that big, guys.
It's impressive though.
Don't start that big.
Hey, but you made everything? I mean,
Yeah.
All graphics, everything?
All.
Wow. That's a lot of work.
It's a lot of work. I'm not kidding with the 5,000 hours, guys. So, yeah, it is crazy. So that's why, welcome to UFO Hunter. I'm making the game together here with Anfinn, who's sitting over there. He's my co-founder in Beachhammer. And we decided to do an entirely different project. It's actually an old game made by Anfinn, 20 years ago, was it? Something like that. In QBasic, DOS, you know, and yeah, it was kind of cool. I've seen the code. It was one file. Not very easy to read though, but it worked. It's kind of like the hacky coding. He's that guy, you know. Yeah. He made it work.
One big game loop.
One big game loop, yeah. So he knows what game loops are. With GoTo and yeah, it kind of rendered differently on different hardware, but that's minor issues. Welcome 2016. He talked to me. Knowing I had that other project, knew a little bit about game programming, game development, so if we can sit together, maybe we could relaunch UFO Hunter in a modern package for handhelds, mobiles, etc. And knowing that that type of game is still very popular, like pixel art is very popular, this fast-paced shooting, retro style, you know, it's really, this is gonna go. So. I sat down, installed Unity. First time I tried Unity. I cloned the original game in less than a week. Learning Unity in the process. And since then it's grown. The feature's grown, it's going to be a complete game. I guess for my part it's 400 hours, quite exactly. From the very get-go I installed Unity until it was released on 4 app stores as the first version, and now we're working on a big update. But I think it tells a different picture than the other project. Start small, guys. Maybe this works like here. We can try. Oh yeah, cool.
Good sound.
Yep. You made it, right?
Yeah.
Yep.
I made that song 20 years ago, actually.
Oh really? It's nice. Sounds authentic.
Reminded of those crack software you used to download.
Yes.
Also, remember?
Yeah, it was made in Fast Tracker. If
Nice.
anyone
We
used
had the
that.
cracking.
Fast Tracker too.
the
Yeah,
cracking
Fast Tracker
software,
too.
Serial key generator.
Yeah, serial key generator. Yeah, that's it.
Yeah.
Good times, yeah. Sorry about the quality of the last video, but we had some rendering issues, but it's gonna be better next.
Yeah.
So YouTube chopped it up a little bit. I just want to go briefly into it. We're nearing the end now. I just show you a little bit about how UFO Hunter was made and the structure and the code. It uses C# as a scripting language, and I just wanted to quickly show like how it started out first as like everything just prototyping, you know, in one big class, and it was very messy. But as well as the project grows, and there's a fine way to do it. Like then you start, okay, I need to refactor, I need to do more structures and have more stuff. So at this point you can see it's actually quite hard to see here. I don't know if it can. Size it up a little bit. So the takeaway here is like, okay, if you start from here, you have a unit class which inherits from mono behavior, which is the base core class in Unity. Everything inherits from a mono behavior. Are you guys familiar, or who else programmers are familiar with object-oriented programming, inheritance and stuff like that? 1, 2, 3, yeah. So you know what's going on here. So to speed up, like, okay, I realize we're making a lot of UFOs here, so maybe I need to do something about it, you know. So okay, I need it. Okay, there is a unit class because every UFO, every player, it needs life and it needs some common things, right? So I don't have to rewrite that every time. Okay, then I have a UFO base class, and then for every UFO which I create after us, I just inherit from the base class. Basically, I don't need to code so much anymore. It's all handled in the base class and just very specific for the new UFOs. But as in the beginning, I had a lot larger classes, you know, not that good structure. This is typical of the project when it goes on and grows in complexity, and you see that the scope is growing. We're actually, it's not a small game anymore, you know. We have features, we have story mode, we're more like different type of gameplays, etc. And it grows, and at one point you need to sit down and restructure it.
UFO 13, that's the descriptive class name.
Yeah.
Do you remember how it looks like? 13?
Yeah.
It is? How many are there?
There are 14. Actually, there are. You're right. It's not a good naming convention. I might need to adopt another one for that. But you can kind of see it in. You don't typically work in so much in Visual Studio or the coding part. You work in the editor. It's just, it takes time to test out all the different bugs. Yeah.
Cool.
Right. Anyone else? Any other questions?
How do you go about the whole, you know, we talk a lot about the development of the game, right? Before, during and after, I guess there's all this concept development and the music and the graphics and deciding what kind of game you're going to do. So maybe asking it in a different way. Do you guys plan to have this kind of retro line of games? Is there a plan here to expand horizontally? Is it,
Yeah.
how is it going to be?
That's a good question. I think we're looking at, we're not specific to retro games, but it's cool. We like retro games, we like the old style of games, and we see that retro art is still very popular today. So, and also to be frank, like if you don't have a big budget for art, now doing retro style might be easier. Like you can do some of the pixels yourself, you know. So the budget for art's in the, but whereas if you do a high fidelity 3D game, you know, then you simply need more man hours to complete the project.
Yeah.
So, but we are looking into many things, not only games. We are we're a game studio, but we're also a software studio. So we're looking into many ways of branching. Yeah, we want to be a franchise, not just limited to a game.
Okay.
Yes, go ahead. I think one over there.
After we had all these new devices that you could create a game on, like handheld devices, how's the competitiveness between the different software or game developers? Have you seen an explosion of competitors to your business?
Yeah, there is. There's a lot of competitors on the mobile platforms.
Yes, no, everyone wants to create the next big game.
Yeah, yeah. There is a huge amount of games and apps released every day. I think it's in excess of 2,000 every day, combined with iOS and Android together, every single day. Not only games, but I mean apps and games. So of course the competition is very fierce. But what we think is, like, you don't get discovered now if you just release a game. It's just going to go in there to the bottom. Nobody's going to see it. It could be the best game in the world. Nobody's going to see it. So there's this entirely other like marketing techniques and so on. You need to work in a more traditional way of getting known. So you need to spend perhaps money, but you need to have the know-how and how to reach out and basically reach out to people. Marketing, social media. That's the key point today of succeeding. Yeah.
I can add one thing on that. There's a lot of the games and apps that are going into the App Store are lots of student projects, and they don't market them at all, and they fall to the bottom like that. So I think it's correct, as John says, that you need a marketing strategy for it.
Strategy, yeah.
And the competition is less in that way than it seems, because a lot don't market at all.
So let's say the sheer volume is not really the competition. It's only the high budget. So if you take away just the hobby project, the student project, etc., you remain with 1%. Like the other 99 is just garbage anyway, because it's just trials.
What you do to kind of stick out of the crowd, if you know what I mean? What do the games that kind of get to the top in the App Store have in common?
Become friends with the best YouTuber in the world.
Okay.
Basically, yeah. You need to reach out. You know, if somebody famous tweet about your game, or you need to get a spin on it. You know, media to write about it because it has it get attention in a special way. You know, like Flappy Bird, for example, the world's most difficult game, and it really got famous when the guy wanted to pull it away from the store and so on. So it's just all these stories, like a little bit craziness needs to go on. Yeah, we need to have a different take on it. Like the game, as long as the game is like good enough, you can have a success if you know how to reach the customer. That's what we think. Yeah. Okay. I think I'll let you go.
Quick question: how are you doing it today? How are you marketing? Obviously, actually, this is marketing. Also, I read about it in the local paper, and
yeah, we.
How?
Yeah, we did have some traction in the local papers. There is an article in Bømmernet, in Sunnhordland. We had an article in Gamer. We've been to game venues. In Stavanger, we had several medias writing about us. So yeah, we're doing what we can, but we still need to step up the effort. You know, this is an ongoing process. It's not a sprint. It's a marathon.
Yeah.
You just have to keep chugging at it. You know, and very often people think. You hear about these successes like Minecraft, overnight, you know, massive success. Well, it did have long tail. What most people don't know is it took like 8 months from it was like released until it got significant traction. And from there on, it exploded. So a lot of these games, they so slow. It doesn't mean if you don't get an instant hit, it doesn't mean it's a failure. It just needs time to get awareness. So yeah, marathon, not a sprint.
And it's much about testing different marketing techniques, because you might have a hypothesis that something will work and it doesn't. So you spend a little bit of money, test out something, and then you test something new and try to find out what actually triggers the customer. and then focus on that.
Is there a business model for this particular game?
There is, yeah. On handhelds, like Android, iOS, we want to use in-app purchasing and also advertisements, right? Ads, basically. So we know that typically the revenue streams for those type of games are 80% through advertisement, 20% through in-app purchasing. So to have upfront cost or like you purchase the game upfront in the app stores doesn't seem to work anymore. Even though the price is like $1, people are not willing to pay. So you have to engage the player for free and get them hooked into the game, into the concept, and willing to spend time there, and then easing the money out of them.
Do you feel like the advertisement can kind of disturb the game in a sense? Would it compromise your concept in a way? Like if you have this really retro concept, it's like everything is just pixel art, and then you have suddenly this flashing something, kind of breaking the whole vibe in it. Is that something?
Yeah.
I don't know.
Not really. I think that would in any game.
Yeah,
would break the experience.
Would you be able to buy away that? Can you pay?
Yeah.
Like,
the intention is if you buy one package, like one pot of gold, basically, the ads go away.
Okay.
That's the idea. So, but it seems like also we need to build the ads in a smart way. Like you have video ads, but if you watch the whole ad, you will gain some benefits within the game. So you need to hook player into actually see the ads, and like you need to create a loop where they're willing to spend time, so that you earn money.
Right now it's totally free, right?
Right now it's totally
No
free.
ads.
Yeah. There's no advertisement, totally free. The version 1, which is released now, that is a learning concept for us. We are collecting data. We see how players play, like how long you play, how many levels you reach, etc. Because we need to, before we go mass market, we need to balance the game. Like, is it too hard? Is it too easy? Why do people drop off? Like, we try to learn and see that based on all that information we take back, and then we will iterate on it and make a better version for the final push.
How do you feel about co-play? Playing
I like it.
together with someone else.
Yes.
In terms of cost, what would that mean in terms of development costs? And do you think that would be? There's this. What's the name of the game? This super well-known Norwegian game, Fun Run.
Fun Run, yeah.
Yeah. So they're like. Their thing was the co-play, right? You could play against other people and.
Yeah. There's definitely added cost to that because I think they're running on servers.
Yeah.
So it's not a localized co-play.
Yeah, no.
It's a remote co-play. So that involves networking on servers and all that stuff. So it's an entirely new level of complexity. So we want to avoid that for now. Like we trying to understand where is the majority of the players. We were very lucky to get in touch with a company called Hipster Wales. They made a hugely successful game called Cross Heroes. We were actually sitting in a Skype meeting with the lead developers there. We asked tons of questions, what works, and because they have like 500 million downloads. Like, what do you earn money from? What do you do? Like, is multiplayer something you want to do? Just like throwing questions, and they were very willing to answer everything. So based on that, I think we have a good view, like at least for that type of game, what worked and what didn't work. What they said was that you would think that multiplayer is a big thing that attracts people, but they said actually they had multiplayer, but they kind of took it away. They saw that that didn't give them the benefit that they expected. Only a small base of players are interested in competing with each other. Most players want to enjoy the game on their own, in their own pace, without having to stay on their toes, being in that competitive element to play the game. You just want to sit on the sofa, on the bus, and relax, and play the game, and fight against the computer in their own leisure. So that was interesting to learn. Like single player is really like the volume of players want single player. Well, I think you go ahead.
Yeah, it's just you mentioned in-app purchasing.
Yes.
Which is something you're considering, obviously. But what's your take on that as a gamer, not as a developer? How do you feel about in-app purchases when you play games?
I'm not a big fan of it. I'm from the old school gamer. I have a job, I have money, so I like to pay up front, get my entertainment, and not being nagged about it. But things have changed. It's not, if you try to fight against the stream, you're gonna struggle a lot. And we know that firsthand from other indie developers who we met at Spill Expo, which was a game venue last November last year. There's some really good game made by a Norwegian developer. We can mention Egg.
Yeah. The game Egg.
Yeah.
From what's the name of the company?
I forgot the name of the company.
But Egg has been a huge success. They have been featured in App Store all over the world internationally.
Egg.
Yeah. It's written E-G-G-G-G-G something.
Well, the thing is like the game has been a huge, you can say success, but relatively not. I mean, because they have been featured by Apple, so they got a lot of eyes, and they said that, and they were honest about this, of 2 million people went in and took a look at they got all the way in and was about to click, but then they saw, oh, they have to buy and not just download. They went away.
It's still like that.
98% left. Only 2% remained and bought the game.
The throw-up game.
Yeah,
it's
the throw-up game.
Because it's
and it's a very good quality game actually. Yes. And it only how much does it cost?
22. I think.
33 NOK.
33.
Yeah. And it's like it's nothing.
But I wouldn't buy it.
33.
No, because I want to test it out. It's a puke game. What?
And that's and that's the problem. So
it's not the money, obviously, right? But it's the push the button and say yes.
Yeah. And that seems to be a huge barrier, unfortunately, on that platform. So it just doesn't work anymore. And then they came up with these new ideas. But what we find interesting, we talked to the younger generation, and they actually ask for features like, oh, so can we have features like watching ads so we get coins and we can do upgrades and stuff like that? Yeah, I think we're gonna make that. Yeah. So you want to be able to have coins and upgrade? Yeah, sure. All games have that. That's cool. That game had that, and so on. And we're like, all right, that's nice to know. So it's just a new type of gamers there.
It's a different mental model than what we have.
Totally different.
We come from the consoles where you had to play your way.
You put coins
there were no
on.
Coins. There were coins in the arcade.
But we do know a little bit about it because we did stand on the corner playing some arcade
on the arcade,
and we putting coins on it. It's the same concept, just another more one.
I guess in many of these games where they make a lot of money on in-app purchase, I guess it's a lot of the revenue is based on a quite small amount of people, isn't it? That some people spend like a ridiculous amount of money.
Yeah.
Where it actually doesn't look that healthy anymore.
Yeah, they call them whales. Basically, they have their own term for that. They
like in the casinos.
Like in the casinos, I think they are less than 1 percentile of the gamers can be qualified as whales, and they are responsible for more than 50% of the revenue the companies earn through the in-app purchasing.
Yeah, because you said it yourself that what you want to have is a game that's addictive, right?
Yeah.
That's what you're aiming for.
Yeah.
So it's a kind of it's something worth thinking about, but it's I understand from your perspective, of course. You want to
I can see
make
how
a
you want
popular
to
game.
make money, but
it's like a psychological.
It ruins the game experience, though. If you want to give someone an experience,
depends. Like we think it can be done rather elegantly. It just depends on how you do it. Like I can see myself playing some games that is not too aggressive on asking me for money or hindering my progress with the game. So there is potential. We think it's potential to have strike a balance there. It's not too invasive, but the big earners are quite invasive. Unfortunately, they take advantage of a human flaw, basically a psychological flaw. It's even a psychologist, was called Skinner, an American psychologist, who found out all about this, how people get addicted. You know, why do people gamble away their house at the casinos and so on? It's the same kind of people that get very addicted and spend unknown amount of money within these games, not really wanting to admit to themselves how much they spent. So,
what happened to the model of which would be the model that I would think I would be comfortable with when I'm buying stuff? Is that, like Joel said, you want to try it.
Yeah.
I'm willing to buy it.
Yeah.
But I want to try it, right?
Yes.
So that's like an obvious model. Let's just give it up free, and you can play for like so and so many courses, or like the first 3 for free, or the first hour for free, or something. What happened to that model? Because you don't see that a lot.
You don't see that a lot. They did try it out quite a bit.
Nintendo tried it with the Super Mario Run.
But it didn't work,
No,
right?
they got very little money.
Yeah, they get very little money. I read articles. There is a very good website called Gamma Sutra. I recommend it if you want to dig into game development and so on. They write huge number of quality articles, and they go through like post-mortem stories like why does that work and why doesn't that work and so on. It seems like if people just try it a little bit, like you, if they don't really like it, they're not gonna buy it. It's just because they tried it and like, yeah, it's good, but it's not, you know, no, it's not 100% for me. It's only 90%, so I'm not gonna buy it. And that's why there's a fall off. Whereas if you have like the ERPs and so on, you get them hooked in another way. Like you just have to progress. Yeah, but I just need to see what happens if I upgrade that tank, or I just need what is behind next door or next level, and then you get into this compulsory disorder, which we all have some of, drive you through the game, you know, and get you basically hooked. You take the fish hooks and you slam it in, and that's how you do it.
Perhaps also if you buy it, if you have bought it up front. Oh, this is the old model, right? I remember when I had this Mega Drive console. The fact that you bought something committed you to play
the game, even though you didn't like it.
I mean, you learned to like it.
Yeah.
You can only
I know. So
you could buy like 2 games a year. So
right.
Yeah.
But it's not all, and this we're talking about in this the mobile space. But still, upfront payment works, like the Steam platform, typical the bastion of PC gaming, or with the consoles, etc. People are willing to pay 500 kroners for a game. That's not a problem. But the production value needs to be. They need to. The gamers are very picky about it. They recognize that okay, there is a team behind this GTA 5 game, right? They spent years making it, hundreds of developers. You see it on the scale of the project and the fidelity of what it gives you. So in that case, players are still willing to shell out the 500 or 600 krona it costs. That's not a problem. So that module still works today, but the production cost is immense.
Yeah.
GTA 5 had a production cost of 1.8 billion Norwegian kroners. Within the first week, they earned 9 billion Norwegian kroners. The scale is just insane, you know. But the cost of investment, if it's a flop, for example, can you imagine you're spending 1.8 billion kroners and then it's a flop? So just the cost of getting into that type of game still lives very well today, but it's not for the small studio.
Have you thought about console development? Have you looked in? Have you tried anything?
We haven't tried, but the beauty now is that Unity supports targeting both Xbox and PlayStation. So you can release the game with small modifications to those platforms as well. I believe now it's some recent changes that more or less the game will automatically become available on Xbox because of some, like this Windows Store available in Xbox and so So that gives us possibility of entry into the Xbox. We still need to research this a little bit more.
I think the PlayStation, from my knowledge, it's at least if the development kit for it is quite expensive. You can't develop on your home PlayStation. You need to buy this special thing, which is quite limited in terms of supply, and it's like 100,000 NOK for it.
That's true.
50 to 100,000, I think.
I think it used to be. I'm not so familiar with how PlayStation Sony does it now.
They put the limit where, I mean, it's from my perspective, that's not. They don't encourage indie developers if they.
That's probably if you want to develop for the, like, to use the whole power of the GPU and everything, right? If you just want to put some games in the store.
I don't think you can put your own. If you buy a PlayStation in the store, you can't just develop a game and test it on that console.
Not just like that. You can have some similar, but to be honest, I'm not so familiar how the Sony does that. But I know that Microsoft and Xbox made some changes. Like you can now make like a UVP app. It's called. It's like this universal code base, which will run on Xbox and Windows 10, etc. So in that case, you are able to release that type of game. It's not tapping into the full power of the console. So you have two ways. If you have developer console, that's the same as Sony does. If you have those who are making GTA run on the Xbox and so on, they will have the developer console, which is have a premium and all that. But I think you can apply for it, and it's not that expensive. They are willing to give it a fairly discounted price. At least I know Microsoft does. So, but I think it's not important for us. Like we reach a certain amount of platforms, but it's not make it or break it. Like if you can be on yet another platform. Like if the game is successful on one platform, just iOS for example, it's way big enough to know if this game is going to be a success or not. Hell, even Mac only will probably tell us if it's going to be a success or not. And then we just expand from there.
Can you say anything about the number, like the relative numbers between the platforms in terms of downloads today? Do you see a weight somewhere?
Yeah, it's you probably know more about it, but it's very interesting numbers actually. But I think that let's say you can say the numbers, but the volume is not representative of probably the true market. But
I was more interested in like the relative.
Exactly.
Like,
I think on the first place it's iOS, iPhones, and on the second place actually surprised us a lot because that was the Mac App Store,
really?
And we have no idea why that happened. As you know, that this is a free game for now, and it seems that there's not so many free games actually on the Mac App Store. So I'm not sure how it would be to make a business model there. But for now that's on the second place, and then we have Android on the third place, and no one use Windows Phone. That's just and we have very
one at home.
We have one for testing.
We have one testing phone. And that's probably the only one.
And actually Windows App Store, no one use that as well. So it works on Windows. You can download it, but most people that have Windows don't even know that there's a micro or Windows App Store.
We have like 30, 40 or something there.
Yeah, something like that. So
they told us more than 2,000 now, I think.
Yeah.
I was going to say who buys stuff on the Windows Store.
Yeah, exactly. I think if we want it for Windows, we need to go Steam, and that's also on our list.
Steam is.
But it's interesting to see. I think though how it scales up. Like it's very dangerous for us to assume too much, of course, based on the one. Like I think in our group of people, like we announce on Facebook, our friends and interested. I think the number, like if you look at what type of devices people have in Norway compared to the world and so on, so we need to look at it on a bigger scale. But I think still, like it's very well known that, for example, the iOS is like it's more profitable. Like the App Store itself earns, I think the Apple earns twice as much money as Google Play still today, whereas they have a market share of 14% worldwide of devices. But they still earn twice as much money, real money. So you want to target those platforms because you know there are paying customers there.
Yeah.
The volume of Androids is just there's a lot of users, but not willing to spend money. You need, so that's why you need to go where people are willing to spend money.
Apple users are used to pay for everything.
But no, but it's not. It's more representative. I think that's just assumption. Like people have more money, like in the first place. So you're willing to spend more money on entertainment and so on. You're not just on a shoestring. You're not on a budget all the time. You're willing to spend money for entertainment. So, but how that ties into advertisement money, I'm not so sure, because there the volume is important.
Right.
That's the key. And as to this day, I think advertisement cuts up like maybe 80% of the revenue is through ads. So that's very, very important to have into account. We also think about having different versions for the iOS and the App Stores, Android, etc. We want to have this advertisement in-app purchasing. Whereas when we go for PC, Steam, or Mac App Store, we want to have you can purchase, because the experience will be different. You can use your keyboard, you can use hardware, a controller, etc. So the game is a vastly different experience. We want to try, and that also gives us good indication what works. You know, we have a different model there, up front on those platforms. So I think we target on PC, Mac. People are more willing to pay up front for a product, whereas on mobiles and handhelds, people are not willing to pay up front. We just meet the customers at their platform. That's what, yeah.